Welcome students. As we discussed in the previous lectures, the meaning of a differential equation, formation of a differential equation, and today we discuss the solution of the differential equation. In particularly, we discuss the solution of first order and first degree differential equation. To solve first order and first degree differential equation, there are number of the methods available mathematically and numerically, but we discuss the method name is variable separable method. So it is possible to arrange all the terms involving x and dx on a one side and the terms involving y and dy on the other side by some transposition. Fx dx equals to fy dy, where this fx is a function of x only and this fy is a function of y only. So in variable separable method, we separate the variables. If we have the two variables x and y only, then variable x on the one side, dx is on the same side, and y and dy on the another side. All the terms which involve x and dx on the one side, y and dy on the another side. Then after separating the variables, then we perform the direct integration to find a general solution of the differential equation. So this is the very easiest method to solve a first order and first degree differential equation. We just separate the terms of x and terms of y with dx and dy. After that, we find a integration. In some cases, sometimes the differential equation are not directly given in a variable separable form. So in some numerical problems, terms are not directly given in variable separable form, or we cannot easily differentiate the terms of x and terms of y on the different sides. So to convert the differential equation into a variable separable form, we use the technique removal of fraction, collection of terms, or some standard forms. So first we discuss variable separable method to solve a differential equation. That means we separate the variables of x and y. Variables of x are with the dx and variables of y with the dy. After separating the variables, then we perform a integration to find a general solution. Now we discuss the numerical based upon the variable separable form. So our first question is, solve the differential equation dy over dx equals to e raised to power x minus y plus x square e raised to power minus y. Firstly, we write the given equation. So from this equation, if we check that this term e raised to power x minus y can be written as e raised to power x into e raised to power minus y. So from this term e raised to power minus y is common. After taking e raised to power minus y is a common, the remaining term is e raised to power x plus x square. Now by separating the variables, we shift the term which contain y and dy on a one side and the terms which contain x and dx on the another side. So this can be written as dy over e raised to power minus y equals to e raised to power x plus x square into dx. We rearrange the terms. Now if we can check that our left hand side contain a variable y with the dy and right hand side contain a variable x with the dx. So we can perform an integration. Now by performing the integration on both sides, dy over e raised to power minus y equals to integration of e raised to power x plus x square dx. So this e raised to power minus y, if we shift this term into the numerator, then in the numerator this become e raised to power y dy integration of e raised to power x integration of x square plus constant of integration. Now the integration of e raised to power y is e raised to power y. Same integration of e raised to power x with respect to x is e raised to power x, and integration of x square is x cube over 3 plus c. Now for the simplification, or to write on this side only term y, we take a log on both sides. If we take the log e raised to power y, we know that log and e are inverse of each other, so this term become a y. Log of e raised to power y become a y and log of this. So our y equals to log of e raised to power x plus x cube plus c, which is our required solution. So to find the solution in this question, first we separate the variable, then we perform a integration. Now we discuss the one more example. Solve 3 e raised to power x tan y dx plus 1 plus e raised to power x secant square y dy. Now the given equation, we can write firstly the given equation. Then after writing the given equation, now we separate the terms of x and terms of y. From this, if we can check that this first term contain dx and 3 e raised to power x. Then on second term 1 plus e raised to power x is a term of x. So we shift this term in the denominator of first term. So if we shift this into the denominator of first term and tan y into the denominator of second term. So our differential equation can be rewritten as 3 e raised to power x plus over 1 plus e raised to power x dx equal plus secant square y over tan y dy. Now this term is the term in x only, and this is a function of y only into dy. So after separating the term, now we perform the integration. 3 is a constant, we can write 3 here. Integration of e raised to power x over 1 plus e raised to power x dx. Integration of secant square y over tan y dy. So 3 times e raised to power x over 1 plus e raised to power x. If we can check that the derivative of 1 plus e raised to power x is e raised to power x. So the derivative of denominator is in its numerator. So the answer for this integration is log of 1 plus e raised to power x, because we know that integration of f dash x over fx dx equals to log of fx. Similarly, the derivative of tan y is secant square y. Again, the derivative of tan y is in our numerator. So this term can be written as log of tan y, and 3 times log of 1 plus e raised to power x. Then we know that log a raised to power m can be written as m log a. So we shift this 3 into the power of this term. Then log tan y. Next we know that log a plus log b equals to log a into b. So this is equals to tan y 1 plus e raised to power x cube equals to c1. Because when we remove a log, we take a exponential on both sides. Exponential and log are cancel out. This is equals to e raised to power c. C is a constant, so e raised to power c is a constant. We can write this constant as a c1. Again, to solve this particular differential equation, firstly we separate the variable, then we perform a integration. Now next example, determine the particular integral of tan x dy equals to y dx, given that y equals to 6 when x equals to pi by 3. So we write the given equation. then dy over y equals to dx over 10x. Now after separation of variables, now we perform a integration. Then after performing the integration of 1 over y with respect to y is log y, and 1 over 10x, we know that 1 over 10x equals to cot x. So log y equals to integration of cot x plus c, and we know that integration of cot x is log sin x plus c. Now here the constant c is involved. To find the particular solution of this differential equation, we require the some particular value of that constant. So to find the particular value of the constant, we use the condition given that y equals to 6 when x equals to pi by 3. So we put x equals to pi by 3 and y equals to 6. Log 6 equals to log sine pi by 3, and we know that log sine pi by 3 is under root 3 by 2. So log 6 minus log under root 3 by 2 equals to c. Then here we apply the formula log a minus log b. We know that log a minus log b equals to log a over b. So this is equals to log 6 into 2 over under root 3. After simplification, we get the value of the constant c equals to log 4 under root 3. So after finding the value of c, we put the value of c here. Then log y equals to log sin x plus log 4 under root 3. Now here these two terms are log m plus log n, or log a plus log b. This is equals to log a into b. Then by taking an anti-log, we remove a log. Our y equals to 4 under root 3 sin x, which is our required solution. Now we discuss the next example. Solve the differential equation xy dy over dx 1 plus x plus y plus xy. Now given equation is this. From this we rewrite this term 1 plus x. From these two terms, if we take y is common, if y is common, this term become a 1 and this term become a x. So this is equals to 1 plus x into 1 plus y. Xy dy over dx equals to 1 plus x 1 plus y. Then after rewriting the term, now we separate the variables by dividing the whole equation with x into 1 plus y. If we divide the whole equation with x into 1 plus y, our equation become y into dy over 1 plus y, 1 plus x over x dx. Now this left hand side has a variable y and dy. This right hand side contain a x with the dx. Now we perform a integration. Now to perform a integration of this term, integration of y over 1 plus y, the degree of numerator and denominator is same. So we know that if the degree of the numerator and denominator is same, then we firstly divide the numerator by a denominator. This is equals to 1 minus 1 over 1 plus y dy. Here 1 over x plus x over x become a 1 plus constant of integration. So integration of 1 with respect to y is y minus integration of 1 over 1 plus y is log 1 plus y. Integration of 1 by x is log x equal plus x plus c. Now y minus x equals to log x. We shift this term into the right hand side, log 1 plus y plus c. So here we apply the formula log a plus log b equals to log a into b. This is equals to log x into 1 plus y plus x plus c. So y equals to log x 1 plus y plus x plus c. That is our required solution. One more problem. Solve the differential equation given dy over dx equals to 4x plus y plus 1 whole square. Now from this, if we can check that we cannot directly separate the variables of x and y. So here we use the concept of substitution because this is our linear factor. We put this factor equals to z. After putting this factor equals to z, we find a differentiation on both sides with respect to x. 4 plus dy over dx equals to dz over dx. So our dy over dx equals to dz over dx minus 4. So after finding the value of dy over dx, we can substitute the value of dy over dx here. And value of dy over dx is dz over dx minus 4 and this term equals to z. So this term equals to z square. So after writing that, we shift this minus 4 onto right hand side, this become plus 4. Now we separate the variable. Dz over z square plus 4 equals to dx. Now we perform a integration. Integration of dz over z square plus 4 equals to integration of dx plus c, where c is a constant of integration. Now here we apply the formula dx over under x square plus a square. The integration of dx over x square plus a square is 1 over a tan inverse x over a. So here the value of a is 2, 1 by 2 tan inverse z by 2 equals to x plus c. At last we put the value of z. Value of z is 4x plus y plus 1. So after putting the value of z, that is our required solution. So in this question we use the concept of substitution because variable separation is not possible directly. So if the variable separation is not possible directly, then by some substitution or by using some another formula we can separate the variable. So if you have any doubt, contact with me.